Okay, let's find some x-intercepts of a polynomial function. All right, this one starts in the general form on the expanded version here. So I think the easiest way to do these is if you're able to factor, go and factor first. Then we can look at the factors and then pick out each one of our zeros or roots or x-intercepts or whatever we're calling them today. All right, so in looking at this polynomial, I notice that we have four terms. Whenever we have four terms, I think it's a good idea to at least look at the possibility of factor by grouping. So if I look at these, I'm going to be in descending order, right? Third degree, second degree, first degree, 0 degree. And I'm going to group the first two terms together and just focus on these two to begin with. So in looking at those two, I think that they have x's in common, right? Both terms have x's. So let's factor out an x squared from each of those terms. So if we pull out an x squared, that's going to leave us with x minus 5. And we can kind of double check if we redistribute, we need to get both of these terms back. Now for factor by grouping to work, what goes in that first set of parentheses has to match what's going to go in this last set of parentheses. So I want to have an x minus 5 in this set of parentheses. So sometimes I just write that out and then think backwards. Positive x multiplied by what would I put out here to give me a negative x? Well, we can put a negative 1 out in front. And then double check, like if we redistribute, negative 1 times x makes negative x. Negative 1 times negative 5 makes positive 5. So it does work out. Now what we want to do is what's inside the set of parentheses goes in one set of parentheses. What's out in front, the x squared minus 1, looking right here and right here, goes into our other set of parentheses. Sometimes students struggle with this and say, I don't see where that comes from. If I give you a side problem of like x squared multiplied by a minus 1 multiplied by a, it's pretty easy to see that both of these have an a in common. You could say that's a common factor. And what's going to go inside if we factor out an a is going to be x squared minus 1. It's pretty similar to what's happening over here where the x minus 5 takes a's place and the x squared minus 1 is like what's hanging out in front. So a little bit difficult. It takes practice to get really comfortable with these, but you'll get it with a little bit of practice. All right, next up, let's finish up. I think we can factor a little bit more. I noticed that we have x squared minus 1. That's two terms, and it's a difference of squares. X squared, that's a perfect square. 1 can be thought of as 1 times 1. So to factor this, let's go x minus 5 comes down. This will be x plus 1 and x minus 1. The order you put the positive and negative doesn't matter. If you multiply this back out, sure enough, we do get the x squared minus 1. I'm not going to do that right now. So what we've done is we've rewritten f of x in factored form. Next, let's pick out the x-intercepts, or sometimes we call these zeros or roots. All right, so how I like doing this is one factor at a time. You just kind of look at this factor and say, there's an x. What would I need to plug in for this x to make this factor equal to 0? Well, 5 minus 5 is going to equal 0. So we get a 0, or x-intercept at 5. X plus 1, if we plugged in a negative 1, that's going to make this factor equal to 0. And since everything's multiplied together, if this is 0 multiplied by everything else, 0 times anything is going to be 0. Finally, with this factor, positive 1 plugged in for that x would make this factor equal 0. So we say 1 is going to be a 0. All right, so those are all of our x-intercepts or zeros. Hope this helps out as you're working on factoring polynomials to pick out their zeros or x-intercepts. Good luck.